Hello and welcome to this presentation of the theme of enterprise data architecture. In a few slides, I will introduce you to the types of repositories needed to build a unified vision of data and its exploitation in data analytics and with AI. Although each company is different, the framework I will present is broad and generic enough to be reusable. It will provide you with the essential benchmark for your enterprise architecture approach. I am Pierre Bonnet from the Engage Meta community. I invite you to visit our website for an overview of our activities and my background. The content of this presentation is published under open source with a Creative Commons license. You are therefore free to reuse it, provided that you attribute the source as Engage Meta community. The first layer of the information system houses the transactional databases necessary for the operation of the company's core business processes. These include your applications, ERPs, and other historical computer systems. The integrity of this data is ensured by strong transactional management in OLTP mode for online transaction processing. The transaction management scope encompasses the relationships between the data, and the system can handle a significant number of simultaneous user access updates. Relational databases are most often used, and they provide great robustness for operational systems. Unfortunately, this layer is often structured in silos. Over time, applications and successive development have been added on top of one another, duplicating some data and complicating the ergonomics of inter-application business processes. To alleviate these issues and address the resulting quality defect, a unified data model, that is an ontology, must be added. That is the subject of the following slide. This presentation does not deal with the gradual redesign of silos to reduce unnecessary data duplications. Please do not hesitate to contact me if you have a need in this area, which we generally address with a data as a product development strategy. In the second layer, the goal is to implement three types of data repositories that are positioned transversally to the silo. They help to correct the quality issues inherent in the silo without imposing their innovation. These three repositories are based on the same unified data model. This is a business representation of data that is valid for the entire company. It is an ontology. The development of this business data model is not easy and requires great expertise in semantic modeling. It can be developed progressively, provided that its foundations are well formalized. Here too, do not hesitate to contact me if you need support on the modeling approach. More specifically, the three repositories of the semantic layers are necessary for the following reasons. One, to correct the data quality defects of the silos. Second, to allow the accumulation of unstructured data, that is knowledge. And third, to prepare the data for use at the level of data analytics and artificial intelligence. Let's now look at the purpose of each of these repositories. The first repository is the Master Data Management, MDM. It deals with the most shared data in the information system, whose lifecycle is not as fast as that of operational data. This involves master data, reference data, and metadata, including a glossary. These data benefit from transactional management in OLTP mode and are supported by governance functions such as version management, traceability, UI for data authoring, etc. The integration of MDM with the operational systems layer is often bidirectional. Therefore, operators can update certain data directly in the MDM to propagate them into the databases of the operational systems. The second repository is the Operational Data Store, ODS. It is a copy of all the data from the operational systems within a single database, mainly structured data. It reuses data from the MDM, which acts as the most reliable source for master data, reference data, and metadata. Often the ODS does not send data back to the operational systems, except when data cleansing operations require resynchronization to the operational systems layer. For instance, a customer data integration, or CDI, is a kind of ODS and will be synchronized with the operational systems in both directions. The coupling of MDM and ODS follows different practices depending on the context and needs. It is important to have a single and same data model for both repositories, which is the ontology I mentioned earlier. Also, the ODS must have rigorous transaction management in OLTP mode. This does not prevent the use of a no-schema database technology for more flexible management. This is also useful for the MDM, which must be able to adapt quickly when the data model evolves. Lastly, the third repository uses knowledge graph technology. You know that the MDM and ODS are based on a predefined data model, even if a no-schema solution is used. But this is not the case with the enterprise knowledge graph, also known as EKG. Indeed, data from the MDM and ODS are located into the EKG in the form of nodes and relationships with direct correspondence. That is, each record from the MDM and ODS becomes a node, and each foreign key becomes a relationship between two nodes. In other words, one could consider that the data schema of the EKG is dynamically elaborated from the data injections from MDM and ODS. This is an approach I qualify as free data schema to differentiate it from no data schema. I do not detail here the differences in database schema techniques, but you should be interested in them to understand the architecture of enterprise data fully. I will probably make another video on this subject, and again, do not hesitate to contact me if you need support. This graph-oriented repository offers several functionalities that are not possible with the MDM and ODS. In particular, first, adding unstructured data, for example in the context of a policy of formalization and accumulation of knowledge. Second, adding text about regulation on which analytical solutions are used on AI trains. Third, creating data graph variant to prepare data set for analytical studies on AI. Since the EKG receives its data from the ODS and MDM, it does not need to implement strict transaction management. It is therefore not OLTP, but SOLTP for Semantic Online Transaction Processing. This means that transaction management is explicitly activated according to the use case needs and driven by application rules. It is not the data management system that inherently guarantees the transactions, but the business layer developed with the EKG. This flexibility is necessary particularly for injecting a massive amount of unstructured data, such as regulatory texts or knowledge repositories. The update cycles of these three types of repositories, MDM, ODS, and EKG, depends on each company's context. Nonetheless, the MDM is the most agile since its data is shared among several systems. For the ODS, some data may require real-time synchronization with operational systems when they participate in real-time automatic decision-making algorithms, especially with AI. On this part, the EKG should be synchronized in real-time with the MDM and ODS. AI should draw from the EKG the real-time data needed for its operation using the RAG technical protocol for retrieval augmented generation. Finally, three other architectural concerns must be taken into account. First, physical materialization of data in these three types of repositories or use of data access virtualization techniques. Second, the level of data history to be retained in these three types of repositories according to the needs and technical capacities for exploitation and storage. Generally, sets of data should be periodically moved to the next layer of data analytics, which relies on mass storage technologies. And third, security for data access, which must be carefully developed. In this third layer, the objective is to establish the repositories required for data analysis. This is the realm of data analytics. Typically, these repositories are not directly connected to data flows from operational systems, but rather to data stream from the semantic layer, namely the MDM, ODS, and EKG. Furthermore, they do not require strict transactional management, but need analytical functionalities that replace OLTP with the OLAP standard for online analytical processing. Traditionally, one finds the data warehouse for processing structured data and the data lake for mass and bulk storage of all types of data, meaning both structured and unstructured. With the rise of cloud computing, physical data storage solutions for large volumes are now available, like key-value storage technologies. However, operating a data lake can be challenging because the data often lack context and can accumulate in a disorganized manner. Managing two repositories, a data warehouse and a data lake, for the same goal of data analysis is not ideal. This is why some software vendors propose a new approach with the concept of data lake warehouse. Essentially, this approach involves adding a metadata management layer to the data lake to provide semantics on top of the bulk data and enable more effective exploitation. The aim is to merge the traditional data warehouse with the data lake. Additionally, some solutions include transaction management to enhance the classical OLAP approach, but they limit the scope of transaction to a single object without considering relationships. This combination of OLAP with atomic OLTP leads to the creation of Atomic Online Analytical Processing, or AOLAP. To finalize the entire architecture, we integrate the AI component, which encompasses both analytical and generative aspects. It draws from dataset originating from the EKG and the data lake warehouse. The AI algorithms and the fine-tuning of AI engines are integrated into operational systems according to specific needs. These algorithms give priority to using data located in the dataset of the EKG and the data lake warehouse, thus avoiding accessing the databases of the operational systems. This approach ensures that the operational systems are not overburdened with additional processing demands and that the AI has access to the most comprehensive and semantically rich datasets available, facilitating more effective and efficient data processing and analyzing. In conclusion, it is important to understand the significance of the four types of repositories that I've just presented: master data management, operational data store, enterprise knowledge graph, and data lake warehouse. They complement the operational databases of the silos and are based on the shared enterprise ontology. The precise implementation of these will depend on your company. You will need to make functional and technical choices to tailor them to your needs and ultimately build your enterprise data architecture. Even if you cannot do everything in one step, it is beneficial to clarify your overall vision to avoid creating additional data management silos in your existing setup, which ultimately will not provide profitability. Finally, the more efficient your enterprise data architecture is, the more you will be able to benefit from data analytics and artificial intelligence. Conversely, with fragile data, you will miss the AI revolution, which can have dangerous consequences for your business. It is crucial to strengthen your data architecture to harness the full potential of modern data analytics and AI technologies. Thank you for following this presentation, and please do not hesitate to contact me and follow me on LinkedIn. See you soon.